This segment of our course on reciprocating compressors deals with bearings and lubrication. First, let's look at the bearings found on most of these machines. The main bearings of the compressor are located on the crankshaft in these approximate positions. They may be either sleeve or roller bearings, depending on the size and requirements of the compressor. These bearings carry the main load of the power transmitted from the driver to the connecting rod of the compressor. This means the bearings must stand up to heavy-duty punishment that is exerted on the crankshaft during the operation. Since you should already be familiar with both sleeve and roller bearings, we will just add that the bearings are normally lubricated by either a splash or pressure lubrication system. We'll tell you more about these in a couple of minutes. The next major part that utilizes bearings is the connecting rod from the crankshaft to the crosshead. As you can see, the connecting rod has a split sleeve bearing in each end. The bearing on the right fits on the crankshaft, and the left bearing fits around the crosshead pin. These bearings are made of cast iron or bronze and lined with babbitt. By looking closely, you'll see that there are gaps between the halves of each of the sleeve bearings. These gaps are to allow the bearing halves to be brought together when adjusting for wear. As the babbitt lining in the bearing begins to wear, the clearance between it and the shaft will increase, as shown in this exaggerated view. When this happens, it is a very simple matter to tighten the adjusting bolt. The result is that the wedge moves upward, its beveled edge forcing the bearing half to the left, adjusting the bearing to the proper clearance. This must be done periodically to maintain proper clearance between the bearings and the crankshaft or crosshead pin. The crosshead bearing is usually lubricated with a pressure oiling system, which supplies oil to the crosshead through tubing. The bearing on the crankshaft is usually supplied oil through passages drilled into the crankshaft. The oil lubricates the crank pin and the connecting rod bearing which fits on it. There are some types of compressors that have a passageway drilled through the connecting rod. The oil forced through the connecting rod may then be used to lubricate the crosshead pin and the connecting rod bearing on the pin. The next bearing is somewhat different. It is the surface of the crosshead that slides back and forth on the crosshead guides. As we told you earlier in the course, they are called crosshead shoes or slippers, since they slip back and forth in the guides. The crosshead shoe has a thick layer of babbitt that is bolted to the crosshead. Shims between the babbitt and the shoe may be used to adjust the clearance between the babbitt slipper and the crosshead guides. If the clearance is too great, a shim of the appropriate thickness is inserted between the babbitt and the shoe. The crosshead guides are an integral part of the frame of the compressor and may be flat or somewhat circular. It is very important that the proper clearance be obtained between the crosshead guides and the babbitt slippers at operating temperatures. If you obtained the correct clearance when the assembly was cold, it would heat up, expand, and eliminate the clearance during operation. This would result in damage to the shoes or the guides. Another important point to remember is that the crosshead shoes must be properly aligned with the crosshead guides. If they are not aligned, the piston rod and piston may be thrown out of line, causing excessive wear to the packing. Those are the primary bearings mounted in most reciprocating compressors. Of course, as we mentioned earlier, the piston is equipped with piston rings which travel back and forth inside the cylinder liner. This could be considered the only other major bearing surface in the compressor we have shown you. Now that you've seen the primary bearings in the machine, let's take a look at the two basic types of lubrication systems which are common to these compressors. Lubricant, as you know, provides a film that reduces friction and wear between moving parts. It also serves as a coolant, carrying away much of the heat generated by the friction. Some compressors utilize a splash system of lubrication, drawing on a supply of lubricating oil in the crankcase. The oil is splashed up by the rotation of the crank and the counterweight. The oil that is splashed is used to lubricate the bearings and the crosshead during the operation of the compressor. In addition to lubricating the bearings, some of the oil splashes into a collecting ring, like this. Since the collecting ring is mounted on the crankshaft, it is spinning at very high speeds. The oil inside the ring is then forced to the outside by centrifugal force. This force pushes the oil up to the crank pin through the passage. And as we mentioned before, it is then transferred to the crosshead bearing and slipper through a passageway in the connecting rod. These systems will vary somewhat from one compressor to another. It's always best to check the manufacturer's manual for the compressor to be sure what kind of lubrication system you're working with. The other type of system we want to show you is the force feed type. In this system, the oil is pumped to all of the required parts, including the bearings and crosshead. The oil pump itself is usually driven by the crankshaft of the compressor, although it could be powered by a separate driver, like an electric motor. First, the pump pulls the oil from the sump through a coarse crankcase strainer, which removes large pieces of foreign matter and residue. It is then pumped through an oil filter designed to remove all remaining dirt and foreign particles from the oil. After the oil passes the filter, it is channeled through an oil cooler, which cools the oil. From this cooler, the oil is forced through a low oil pressure alarm. And then into the oil header. The oil header then distributes the oil to the various parts requiring lubrication in the compressor. There are also 3 safety valves built into the system we are showing you. The first valve is a bypass relief valve. If the oil filter becomes blocked or plugged, the relief valve opens, allowing the impure oil to return to the oil sump. Since there will no longer be oil going through the system, the low-pressure alarm will shut the compressor down. This is very important, since a machine like this cannot operate without oil, or it would burn up. The other bypass valve shown is between the oil filter and the oil cooler. This valve is thermostatically controlled to keep the oil at the proper temperature. If the oil is too cool, the valve bypasses the oil cooler. This is done because the use of oil which is cooler than 125 degrees can lead to the condensation of water inside the crankcase. This results in sludging of the oil, creating excessive wear. That concludes this segment of our module dealing with bearings and lubrication. As you have seen, both bearings and lubrication systems can vary. Our objective was to acquaint you with the most common types and how they are used in the operation of a reciprocating compressor. If you're in doubt about a compressor you'll be working on, check the manufacturer's manual or consult your supervisor. He'll be glad to help out. We have some questions for you now on bearings and lubrication. You'll find them in exercise number 5 in your workbook.